let's just talk about the graphs now. So I mentioned earlier that you need to be able to plot values, so you need to be able to plot those points, but you also need to be able to read and interpret your graph. So from a distance time graph, can you all tell me some things that you could get out of a distance time graph? Alright, so I just heard somebody say speed. So from a distance time graph, we can get speed. So we'll talk about that in a little bit. What else can we get from a distance time graph? Alright, so I just heard displacement. Anything else? What can you get from a distance time graph? So I heard the speed, which deals with you being able to analyze the graph, which is good. I heard about displacement earlier, and there's just something very, very, very simple. What can you get from a distance time graph? Anybody? Think about it. Yeah, distance. That's it. Something very, very simple, isn't it? You can tell on a distance time graph when you represent the entire journey of whether it's a car in motion, a person in motion, whatever. If you have a distance time graph, you could actually tell the distance they traveled over a specific amount of time. You could identify how much distance they covered at any point in time in the journey. Alright? So that's what you could get out of a distance time graph. The speed comes out of analyzing your distance time graph. Anybody wants to tell me where they think they could get the speed that the body moves at? If from a distance time graph, how are you getting the speed of the body? Anybody? How are you getting the speed? Okay, so I just heard somebody say the area underneath the lines. Okay, so area underneath the lines. Okay, so let's just find out how many people think that if they want to get the speed, let's just say this was a car in motion, right? How many people think that the area underneath this graph is going to give us the speed of the car? Raise your hand if you think so. Do you think the area under the graph is going to give you the speed of the car? Raise your hand if you agree with that. This is quite interesting. Calissa, Calissa, you don't agree with yourself anymore? Alright, so Calissa does not agree with herself anymore. Alright, so if I were to look at a distance time graph, and let's say I wanted to get the speed of this car in motion. The speed comes from me being able to analyze the graph. And when I say analyze the graph, when we look at a graph, I mean, yes, there are points that we plot and whatnot. This particular type of graph forms a shape that you can find the area under the graph. But there's something about the lines. Miss, would it be by dividing? Okay, let me just read what she says. So Rihanna is saying dividing the distance by the time or something like that. Yes, dividing the distance by time. So let's just go back to Form 3. You all would have done some basic things in physics. And I believe you all would have learned about the formula for speed and velocity and acceleration, etc. Right? Do you remember the formula for speed? There you go, distance over time. So exactly what Rihanna just mentioned in the chat. You will divide the distance by the time. From a mathematical point of view now, anybody wants to tell me what in particular about the graph is going to give me the speed? Yes, you divide distance by time. Yes, that's the formula, but what can I analyze from this graph that is going to give me the speed of the vehicle? There we go. The gradient. The gradient. Y'all, how many people here remember that you could find the gradient of a line? Raise your hand if you remember you could find the gradient of a line. Can you find the gradient of a line? Alright, look, Calissa raised her hand, so this time she agrees with herself. So I've seen a few hands popping up. If you can recall, from the time you started doing things like coordinate geometry and graphs, I've seen a few more hands pop up. Alright? If you remember those things, you'll remember as well that a characteristic of any line segment in the coordinate plane is that it has a slope. That slope, aka gradient, is going to tell us something. Alright? So in terms of the coordinate geometry, is to look at the slope mainly for steepness, but in cases where you are doing some sort of real life application, you will be able to analyze the slope of the graph and you'll be able to get some information. And one of the things in this case, if we were to find the slope of this graph, we will get the speed of the graph, right? So the gradient m is equal to the speed of the object, all right? So if ever you have a distance time graph and you're asked to find the speed, what do you need to find? So if I give you a distance time graph and I tell you what is this, find what is the speed for me, what is the speed of the object during a particular part of the journey, how will you find that speed? What we just say? The gradient of the graph, yes. Listen, I know it's Monday and we're real kind of like not too keen on a Monday, and then we have maths on a Monday, early on a Monday, but kind of, respond a little bit. I see some people get a little exercise when they had to raise the hand just now and sing. At least, alright? Put a little effort. Give yourself a little jolt to start your day. So, whenever you deal with a distance time graph and you need to get the speed of the object, you are finding the gradient of the line. Alright? Now, something that you might notice with travel graphs, you'll notice something with the shape of it, right? So, yes, you have a shape being formed, but you'll notice that it slopes upwards here, and then it's flat line in here, and then it slopes downwards. You'll notice that? Alright, I can't really see the heads nodding if you're nodding your heads, but do you all notice that the lines, we have a portion of the travel graph that is sloping upwards, a portion where it is just like a flat line, it's horizontal, and then there's a portion of the graph that is sloping downwards. You'll see this, you'll see what I'm talking about. Okay, lovely, thank you. So, when we talk about travel graphs, this is something else that we're going to notice. It's not like a typical equation of a straight line type of graph. The travel graph is going to represent the entire journey for something, whether it be a car in motion, a dog in motion, an athlete running. It's going to represent a journey. And you notice that the graph starts at 0. Right? It starts at your origin, starts at 0. 0 time, 0 distance covered. But then gradually the line increases, it flattens, and then it has a decreasing slope. So, can anybody tell me what's happening? Let me just label this piece as, let's see. Wow. Undo that. Okay, so let's say I label here, right? As, let's say I call that T1, and then I call this piece T2, and then finally we have T3. Okay, can anybody tell me what they think is happening between 0 and T1? Tell me what you think is happening between 0 and T1. So I'm talking about this portion of the graph. Yes? Okay, so I heard acceleration. I wonder if acceleration is a correct way to term it, but we'll keep that in mind. So I'm hearing somebody saying acceleration. Anybody else wants to share with us what they think is happening? So just keep in mind it's a distance time graph. We said that the gradient is going to give us the speed of the object. So tell me, what do you think is happening between 0 and T1? So there we go. So we're hearing something about distance is increasing while time is increasing. So what sort of action do you think is taking place? So think about it. Like I said, it's a car in motion, right? It's a car. What do you think is happening to the car between 0 and T1, where this line is increasing in gradient? So as she mentioned, the distance is increasing and time is increasing. So what do you think is the action taking place at that point in time? Okay, the speed. Okay, all right. I'll entertain one more response and then we're going to talk a little bit more about that. So what do you think is happening between 0 and T1? Anybody? What do you think is happening to the car between 0 and T1? Think of an action. Yes? Alright. So, you all can take a look at the chat. Ravisha just mentioned something and she's a little bit indifferent about her response. But Alyssa just explains us what is happening on this particular journey. She explained the entire journey essentially, right? The car is moving. So from 0 to T1, the car is in motion, as Ravisha is saying. The car is in motion. It is moving. And as Alyssa explained, it's starting from 0. It's going somewhere. And then she mentioned, it's stopping and then it's returning. All right. So when you deal with a travel graph, you will have some journeys where they take you from a particular location to another location. You might have some rest and then you'll have a return trip. All right. So this is what your distance time graphs will be looking like. If you have a body in motion, it comes to a state of rest and then it is returning. So how do we know that the body is in motion during 0 to T1? Simply because, as Calissa was explaining it just now, she said she's noticing that the distance during this portion of the graph, the distance is going to be increasing while time is increasing. So basically it's showing that as the time is progressing, it is covering distance, right? That's what is telling you motion is taking place here, movement is happening. And I was going to ask afterwards, what is happening between T1 and T2? Okay, what do you think is happening between T1 and T2? So, again, a lot of these things that we're talking about right now is just you actually tapping into your knowledge of coordinate geometry here, because in order for this to have an increase in slope, it means something has to be happening. We did say that the gradient is telling us the speed of the object. And if I ask you all, so this is what I was going to ask you all afterwards. if an object has a speed, I have a question, which is, do you think the body is moving or do you think it is resting? Will a body at rest have a speed? And obviously the answer to that is no. A body at rest will have no speed at all. It's not moving. It can't accelerate either. And like I just said, it won't have speed because it's not moving any sort of distance over time. It will just have the body being there at a state of rest. So this is the reason why we know during this particular portion of the graph there is movement. All right, distance is being covered over a period of time. Now, like I was about to ask the question, which Alyssa has already explained, is this. Between T1 and T2, you notice that the line is flat. So let's look at it from that coordinate geometry perspective. What is the gradient of this section of the graph here? Anybody? What is the gradient? What is the gradient of that section of the graph between T1 and T2? Okay, so she says the car is at rest. Car isn't moving. So I have a question. It comes back again to what we were just talking about. If I ask you all, what is the gradient of this point here between T1 and T2? Alright, so Ravisha is asking if it's constant. I have a question. Gradient. Think about what I just asked. What is the gradient between T1 and T2? Anybody here could tell me what is the gradient between T1 and T2? Okay. Okay. The section of the graph that I'm asking about, so maybe this will give you clarity. Alright, so I just hit it 0. But look at this. Between T1 and T2, I'm looking at this little piece of the graph here, right? This straight line here. Yes or no? Between T1 and T2, am I looking at this little piece of the graph here? Okay, tough crowd today. So, Kalissa has provided us with the answer because, as Alyssa was saying earlier, the car isn't moving during this period of time between T1 and T2. The car isn't in motion. The car is just like right, whatever distance it covered, that's where it is. It's just there, right? There is no movement because the distance stays the same although the time is progressing. And that could be modeled by a number of real life scenarios, right? But I was just asking the question, if you were looking at this section, which I said is like a flat line, right? It's horizontal. The graph goes horizontal at this point. What is the gradient of the horizontal line? So let me see what Rihanna says. Rihanna says yes. Alright. So I'm asking the question again. And like I said, tap into your coordinate geometry knowledge. Go back to form 3. What is the gradient of a horizontal line? If you can answer that question, then we could make the connection between no movement, body at rest, car not moving, no speed. What is the gradient here? Anybody? Thank you. 0, 0. Who said 0? Alright, lovely, Misha. Lovely. Thank you. Alright? Yes, the answer is 0. Okay? Between T1 and T2, like I was saying, it's horizontal. And even when Alyssa said that the car isn't moving between T1 and T2, this should hint to you, right? If the car isn't moving, it means it has no speed. Alright? It means it has no speed. And if something has no speed, like I was saying earlier, something at rest, something at rest will not have any sort of speed because it's not in motion. Okay, so over here the body was at rest, the car was at rest, it was parked up in somebody's garage, and then it started moving, right? It started moving, and then all of a sudden it stopped moving at this point in time because the distance is the same. It's not moving anymore. It's just staying at this particular distance. Time is passing, but the body is just at rest during this particular period of time because the gradient here is 0. All right. So I want you all, like I was saying just now, if you can recollect your basic understanding of some of the things from coordinate geometry with straight lines, analyzing this and making sense of it, it becomes a little bit easier. Okay? Becomes a little bit easier. So over here, your gradient is 0. Your gradient is 0. The body is not moving. Alright? And if I were to ask you, okay, what is the speed of the vehicle at this point in time, you'd still tell me it's 0, let's just say kilometers per hour. Alright? So if you ever have to analyze a distance time graph and you notice that there is a flat line portion of the graph, horizontal like this, instantly you should think that the body is at rest during this particular period because it's horizontal. The gradient will be 0, which means that the body is not moving. Okay? And the final part shows us a decreasing gradient. Alright? In a distance time graph, as well as a speed time graph, alright, that will be interpreted differently. In a distance time graph, this decreasing gradient is actually representing a change in direction. You're moving in a different direction. Okay? And when you move in a different direction, it's indicative of something like a return trip. So this could be, somebody was on their way to work, they get stuck in standstill traffic and then take the nearest turn back home, right? So this is one of those distance time graphs. Like I was saying, you have motion in the first portion of your graph, no motion through the middle of the journey, and then you have a return trip. Okay, so like I said, it could be that it was just another Monday and Dominique was on her way to work, jump in her car and she going down the road, but then she meets standstill traffic and she was like, I really wasn't in the mood to go to work in the first place today. So she see the traffic standstill, she not really moving, time just passing her by, and she just getting fed up and more frustrated, and it's like, what is the point of going to work? So she just looks for the nearest turn off, turns around and goes all the way back home. End of the day. Okay, this could also be represented too in some scenarios as I leave my house, I go to run some errands by the mall, so my vehicle is parked up, and then when I'm done running my errands, I jump back in my car and I get back home. Alright, so those are some real life scenarios where you could model a journey for a distance on a distance time graph.